Hi everyone. This is part one of a two-part video where I will show you how to do a t-test using R and how to evaluate both the statistical and the practical significance of the results. All right. Okay, so before we jump into R to show you how to do a t-test using R, let me remind you of a couple of things that you need to actually remember in order to understand the logic of the t-test. The first thing I want you to remember is that the goal of a t-test is to compare the means of two populations. So to compare the means of two random variables. And if you want to compare the means of two populations, you need to rely on two samples. So you need to take a sample from each population because remember, it's very difficult to access a whole population. So we need to rely on a sample. And when you do that, when you rely on a sample to make inferences about a population, you actually are kind of the way this goes is that you have a supposition, a hypothesis about the populations, and then using the data from the sample, you want to see if that supposition, that hypothesis, is supported by what you see in the sample. Okay, in other words, so when you're doing this test, you are going to have a supposition about the two populations, and from the two samples that you take, you are going to see if that supposition is supported or not. Okay. Now, the thing is, in statistics, we don't have only one hypothesis or one supposition. We actually have two. So we have what we call a null hypothesis and also an alternative hypothesis, which is what is supported by the data when the null hypothesis is not supported. Okay, so in a statistic, we actually work with two hypotheses, HO and HA, or HO and H1. And when you're doing a t-test to compare two means, you can actually be working with either of these three pairs. So we have three pairs of hypotheses here, and the specific pair that you are working with depends on the problem that you're facing. Okay. But the idea is that you start the t-test by selecting one of these three pairs. Okay. Um, all right. So knowing that, let's go ahead and jump into R to show you how to do a t-test. And first, of course, I'm going to show you how to do a t-test using a specific example, okay? Um, Before we discuss the example, take a look here at my interface and notice that I'm actually using RStudio, okay? I'm using RStudio, which is an IDE for R, okay? Very convenient way of programming, of using R, of writing R code, okay? RStudio. And with RStudio, I went ahead and created a notebook. This .rmd file is actually an R notebook, and a notebook is, as you will see right here, it's a very convenient way of including text, code, the output from your code, everything in one place. Okay, so that's why I'm using an R notebook. All right. Okay, so the specific problem we're facing here is related to um, um, a hotel and two type of guests, so domestic guest and foreign guest. And what they wanted to do was to compare the ratings given by the two type of guests, domestic versus foreign guest. Okay, and the management of that hotel had a specific claim in mind. So they suspected that domestic guests give higher scores on average than foreign ones. Okay, so that's the claim that they wanted to test. Okay. All right. For this problem, there's actually data available. I have that data stored in a CSV file locally. So I have that CSV file stored in my computer. Okay. And as you will see right now in that CSV file, what I have is only two columns, just domestic scores, like one column for domestic scores and another column for foreign scores or ratings. What I'm going to do is, as you can see here, I'm going to read that CSV file into a data frame. So I decided to name my data frame like this. To do that reading, I'm going to use the read.csv function that allows me to read a CSV into a data frame. Okay. Let's go ahead and execute this code cell. And now in this next code cell, let's take a look at that data frame using the structure function, okay? Notice that in that data frame, as I said earlier, we have two columns only, one with domestic scores, okay? This is a sample of the domestic scores, and another one with the foreign scores. And we have 43 observations for each column. And that's an important number because, as I said here, notice that both samples are above 30. So each sample has more than 30 elements. And that's important because when the sample sizes are above 30, you can safely assume that the sample means follow a normal distribution. And then that means that the test statistic follows a t-distribution. That's one of the assumptions when you're doing a t-test. So you need to make sure that the sample means follow a normal distribution. And that could happen in two ways. Either the variables, the random variables, in this case, the scores, either they follow a normal distribution or the sample sizes are above 30. In this case, because the sample sizes are above 30, we can safely assume that the sample means follow a normal distribution, which means that the test statistic follows a t-distribution. Okay. Well, that's an important assumption. I just wanted to mention it. And after that, we can go ahead and conduct the t-test. Now, as I said earlier, when you're doing a t-test, you're actually testing a pair of hypotheses. Okay, so what is the pair of hypotheses we're testing here? It depends on the claim. What is the claim that we're trying to test in this specific problem? Well, this right here. That is the claim that they want to find evidence for to see if domestic guests, the average for domestic guests is higher than the average for foreign ones, okay? So at the end of the day, the claim that they are testing is this one. Average for domestic guests is higher than the average for foreign ones, okay? And that will be our alternative hypothesis, our H1 hypothesis. Remember that in statistics, the claim that you're testing goes in the alternative hypothesis. Don't forget that your claim goes in the alternative hypothesis, and then the null hypothesis, HO, is the opposite, okay? Which in this case is that the average of domestic is less than or equal than the average of foreign ones, okay? Knowing the hypothesis that we are testing, we can go ahead and actually do the t-test. And to do the t-test in R, a very easy way is to use this built-in function, which is t.test, okay? And that's the function we're going to use in this video. And that function takes a few arguments. Let me explain the arguments that it takes. The first two arguments are just the data. Argument number one, comma, argument number two. So this is just the data for the domestic guest, okay? And then the data for the foreign guest, okay? And by data, I mean the ratings, okay? All right, so those are the first two arguments. And then the third argument is what kind of alternative hypothesis do you have? In this case, our alternative hypothesis is a greater than hypothesis. So that's why here I used the text greater, okay? If you were doing a less than, you will type in less. If you were doing a not equal to, you will type in two dot cited, okay? But in this case, we're doing a greater than alternative hypothesis. So that's why alternative is greater, okay? The next argument is what kind of sampling you are doing. Are you doing a pair sampling or an independent sampling? In this case, we are not doing a pair sampling. So that's why I'm saying paired false. We are doing an independent sampling because we're taking independent, different samples from each population. So we're taking a sample of domestic guests and a totally different sample of rating guests, of foreign guests. Okay. And then we're getting the ratings for both samples. Okay. And in this video, I'm not going to discuss the difference between pair sampling and independent sampling, but it's important for you to know that that's a decision you need to make. Are we using a pair sampling or independent? In this case, we are not using pair sampling, we're using independent. And the last argument is how about the variances? So the t-test is to compare the means of the two populations, but how about the variances? So can you consider the variances to be equal or not? In this case, I'm assuming that the variances are equal. So that's what I'm saying. Bar dot equals true. Okay. Why am I doing this? Because earlier I ran a test to check for the variances. It's a different test. It's not the t-test, totally different test. And from that test, I had evidence to conclude that the variances were the same. So that's why I'm using bar equals true. Again, discussing that test to compare variances is beyond the scope of this video, but it could be a different video. But yeah, I want you to know that I'm selecting this option because I ran that test. If you are unsure, I guess the most conservative approach is to say bar equals false. So the most conservative approach is to consider that the variances are not equal. So if you don't have any information, it's better if you do bar equals false, okay? But in this case, I have evidence to conclude that they are the same. So that's why I'm using this option. All right. Knowing this, we can go ahead and run the t-test, and then this is the this is the output we get. Notice first, look at the bottom of the output. Here we have the sample rating for domestic and the sample rating for foreigns. And notice that, well, the sample rating for domestic is higher than the sample for than the sample rating for foreigns. Okay, so it looks like we can go ahead and claim that yes, the average for domestic is higher than the average for foreigns. Well, this is a difference in the sample. Okay, so does that difference actually hold at the population level? We don't know. So in a sample, we will always find differences. Okay, but is that difference statistically significant? In other words, can you safely conclude that that difference will show up at the population level as well? Okay, we don't know because, again, just because we see a difference here, we cannot claim that that difference will also hold at the population level. We need to find evidence as to whether that difference is statistically significant or not. And that evidence comes from the p-value. Okay, take a look at that row right there. In that row, we have the t-test statistic for this test. Its corresponding degrees of freedom. It's, as I said, it's a test statistic that follows a tree distribution with its degrees of freedom. And then using the test statistic and the degrees of freedom, we can get the p-value, okay? The p-value is very, very small, 0.006. And how do we use that p-value to evaluate statistical significance, guys? Well, we need to compare that p-value with alpha, or the significance level. Alpha, or significance level, is something that we establish before we run the t-test, okay? And usually you establish an alpha of 0.05. At least that's the most widely used alpha, okay? And that's the one we're going to use in this case. So we're going to assume that our alpha, the alpha we're using, is 0.05. And what we do is we compare this p-value to alpha, and notice that that p-value, that number, is less than alpha, okay? It's less than 0.05. So when that happens, then you are able to conclude that um, you are able to reject HO and support HA, okay? So whenever the p-value is less than alpha, you're able to reject HO and support HA or H1, okay? And so if you're supporting H1 in this case, what are you saying? You are saying that, okay, so the samples are giving us evidence to conclude that this difference that we are observing here also happens at the population level. Okay, so in other words, we can conclude that the average score for domestic guests is actually larger than the average score for foreign ones. Okay, but we can make that leap from the sample to the population because we found that the p-value was less than alpha. So that's the way you evaluate statistical significance using a t-test. You compare the p-value to alpha, and if the p-value is less than alpha, you conclude that what you are observing in the sample also translate at the population level, okay? Okay, that's great. That's statistical significance. But then we need to now evaluate practical significance, which is a different thing. Okay, it's a totally different thing. And that will be part two. That will be part two of this video. In part two, I will show you how to evaluate practical significance. I wrote all the conclusions about statistical significance right here, which is what I just said. Okay, but if you want to read, you can go ahead and pause the video, and then you can read what I wrote for you here. But yeah, I will see you in part two to now continue with the evaluation of practical significance. Okay. All right. All right. I will see you in part two, guys.